Hello ladies and gentlemen, welcome to today's webcast. My name is Thomas Chiu and I'll be your host for today's session. Before I hand over to our presenter, Travis, who will be sharing with you on Infineon XMC4800 EtherCAT, which is the first ever EtherCAT node on an ARM Core Cortex-M32-bit microcontroller with on-chip flash and analog mixed signal capabilities. During the session, he will also demonstrate to you how the integration using the TwinCAT with XMC4800 Relaxed Kit to control the LED. Now, let me share with you on some basic information about our broadcasting system. Please note that the quality of the stream depends on your internet connection. We will provide you with 3 different streams to cover all possible devices. So it doesn't matter if you're watching from your desktop, your notebook, or your smartphone. During the session, if you have any question, you can always use the chat function to post your questions. Or you can send your email at webcast@infineon.com. Now I'll hand over to the presenter. Stay tuned, we'll be back to you in a moment.
Hi, my name is Travis. I'm the application engineer from Infineon, taking care of the XMC microcontroller. Today, it's my pleasure to introduce you the XMC4800 EtherCAT microcontroller. After that, I will also show you getting started on how you can actually implement an EtherCAT slave using the XMC4800 Relaxed Intercap Kit. So without further ado, I'll show you the agenda for today. Today's agenda will cover 4 topics. The first topic is the XMC4000 roadmap and key features. After that, I'll show you a preview of the XMC4800 Relaxed EtherCAT Kit. Then we will run through the toolchain that is actually necessary to build out an EtherCAT slave. Finally, we will do a getting started demo to implement an EtherCAT slave using the XMC4800 Relaxed Kit. The first topic of the agenda, XMC4000 roadmap and key features. This slide shows the XMC4000 family roadmap. The XMC4000 microcontrollers are all equipped with ARM Cortex-M4 CPU, which is able to deliver frequency up to 144 MHz. Beside the high-performance CPU, the microcontrollers are equipped with high-performance peripherals, such as the high-resolution PWM, event request unit, high-speed analog comparator, timer for inverter control, and also the delta sigma demodulator. These peripherals make it very suitable for application to be used in motor control, digital power conversion, touch sense, and also even to be used in application for automation. As a highlight, the XMC4800 and XMC4300 is the first ever highly integrated microcontroller with EtherCAT solution. With this new communication protocol, we are able to provide real-time Ethernet communication in the application for automation. The XMC4800 comes with the largest pin count of 196 pins to the smallest pin count of 100 pins. It is also packed with 2 MB of flash and 352 KB of RAM. If you feel that the XMC4800 is too much for your application, you can also consider a smaller size XMC4300, which also comes with the EtherCAT protocol. The XMC4300 comes in a smaller package of 100 pins and is packed with a flash size of 256 KB and 128 KB of RAM. On the next few slides, I'll share with you some of the key features of using this EtherCAT microcontroller. The first key features which I'm going to mention to you is the smallest fully integrated EtherCAT slave. Before this integrated solution comes into light, to implement an EtherCAT solution requires either an ASIC or a FPGA. And these two solutions requires additional component. For example, to use an ASIC solution requires a microcontroller. This is because the microcontroller is required to process EtherCAT data, and the microcontroller also provide additional support for other peripherals such as the ADC or even with the PWM generation. As for the ASIC side, the ASIC also requires an external E2PROM, which is interfaced by using a I2C bus. To power up the microcontroller and the EtherCAT ASIC, it also requires two additional clock sources. The next solution is to be using the FPGA solution. However, using the FPGA solution doesn't come with a huge advantage. This is because the FPGA needs external memory and are usually big in sizes, which occupy a large area of the PCB. Now, with the XMC4800, is able to combine all that is required inside a 100-pin package. Therefore, no external component is needed and is easily to be handled in the PCB production. As a microcontroller itself is able to bundle with many peripherals to provide a single chip solution. Other than that, it also comes with many package options which is available to meet your design needs. The next key features is the full compatibility with backoff ET1100 ASIC. In any case, if you have the intention to do a migration from the backoff ET1100 to XMC4800, you can be sure that the migration is an easy one. This is because the XMC4800 is implanted with a backoff ET1100 ASIC inside the chip. And it has got the following features of the ET1100 ASIC, such as the 2 MII port for Ethernet 5, 8 sync manager, 8 field bus memory management unit, 8 KB of processed data RAM, and lastly 64-bit of distribution clock for clock synchronization. Lastly, do note that the register interface are exactly the same. Hence, easy porting of existing software from ET1100 to XMC4800 is 100% compatible. The last key features is the multiple on-chip triggers connection. In order to have all the EtherCAT slaves within the network to perform synchronous action or tasks, we can actually make use of the distributed clock. The distributed clock will ensure clock synchronization between the master and the slave. However, having a synchronized clock doesn't provide a real synchronized function. Therefore, hardware is needed to be implemented together with the distributed clock to provide a pulse at a fixed timing. And this pulse is known as the sync signal or the sync pulse. In the XMC4800, the sync pulse can be used to trigger the ADC or the event request unit, the ERU. The sync pulse can also be sent out to the digital board as an updating status. As for the latch signal is connected to the event request unit and also to the digital I/O port. In the event of any input signal, the input signal can be latched in and create a timestamp which will be feedback to the EtherCAT master. Now, I'll show you on the next topic of the agenda, which is the XMC4800 Relaxed Intercap Kit. The XMC4800 Relaxed Intercap Kit consists of two parts: the Relaxed Kit itself and the EtherCAT 5 board. On the XMC4800 Relaxed Kit, you will find the onboard debugger with a power-on USB. Besides this, it also comes with other interface and connections such as the SD card, Ethernet, buttons, LED, and USB. So you require to run the EtherCAT protocol, you have to make use of the EtherCAT 5 port, which is required to be connect or piggyback onto the XMC4800 Relaxed Kit. Using the XMC4800 Relaxed Intercap Kit, you can have a comprehensive evaluation of the microcontroller. On the next topic in the agenda list, we will touch a bit on the EtherCAT slave toolchain for XMC. The EtherCAT toolchain consists of 3 tools. The first tool is for the EtherCAT master and is known as the backoff TwinCAT 2 or TwinCAT 3. Both of these software can be downloaded from the backoff website. The TwinCAT 2 offers a 30-day trial period, whereas the TwinCAT 3 has got no trial period but has a usability limitation. The second tool is for the EtherCAT slave and master. It is known as the slave stack code tool, or popularly known as the SSC. The SSC tool is used for the generation of the slave stack code for the slave, and it also will generate a ESI file for the master. The ESI actually stands for EtherCAT Slave Information File. The last tool is the Infineon Day4. The Day4 is a code generator, is also a compiler and a debugger. Besides this, the Day also provides software apps to address peripheral configuration for specific application. So using a Day4, you can ensure to have convenience for your software development. Now, I shall show you the procedures to create an EtherCAT slave with the mentioned toolchains which I have actually mentioned before. For the step 1, we make use of the Infineon Day4 to create a project for XMC4800. Then using this project, we will activate the EtherCAT apps, which will create the software to configure the EtherCAT file. And it also provides other low-level driver for other peripherals. Step 2, we make use of this SSC tool. First, we create an application description file for variable mapping. Then the SSC tools will actually read into this file, which will generate the slave stack code for the slave. Besides this, it will also generate the ESI file for the master. The third step is to combine the software that is generated from the Dave and the SSC tool. Then we do a compile using the Dave tool and we ensure that there's no compilation error and the hex code is generated, and we can download the software into the XMC4800 slave. The last step is to copy the ESI file into the EtherCAT master. This is to ensure that both the master and slave has compatibility to one another. Now, the last part, I will show you getting started with EtherCAT slave using the XMC4800 Relaxed Intercap Kit. The objective of this demo is to guide you on how to use the backoff SSC tools to create the slave stack code, and also to make use of the Dave to activate the EtherCAT apps to configure the EtherCAT file. From this example, you will be able to have two functions. The first function is to make use of the EtherCAT master to control the LEDs. And the second function is to make use of the EtherCAT master to read the buttons from the Relaxed Kit. Before we start our demo, I would like you to have your USB and Ethernet cable to be connected in the following manner. Now, I'm going to switch my laptop from the PowerPoint slide to the Infineon Day4. So let's get started. First of all, I had created a workspace in C drive called workspace EtherCAT. So for this demo, and we shall place all our EtherCAT project into this workspace. Now, let's trigger the day 4 to start a new project. So we point our workspace to the folder or directory that we had created previously and click on the OK button. To create Dave project, then we provide a name to Dave project. Then we provide a name to the project called XMC4800 In the project type, select Dave CE project and click on the next button. In the microcontroller selection page, we select the XMC4800 F144 by 2048 microcontroller, which is found on the XMC4800 Relaxed Intercap Kit. Then we click on the Finish button. Once the project is created, you should be able to see the following folder: the Dave, library, startup, and the main.c file is created. So for the next step, we need to activate the EtherCAT apps. To do so, click on the Add New App icon. With that, the Add New App window will appear to provide a selection of apps. Click on Communication, followed by Industrial, then select the app ECAT SSC. Add the selected app by clicking on the Add button. Finally, click on the Close button after the app is added to the project. At the App Dependency window, we can find the ECAT SSC app. To have a view of the general setting, double-click on the ECAT SSC app. At the general setting, please ensure that the Enable File Management interface is checked, and for the rest, we shall stay with the default configuration. Now we are about to configure the file. The file configuration consists of 36 I/O pins, which is connected to the MII ports of the EtherCAT module. To know the I/O pins configuration to the file, you can simply click on the Help and selecting the Help content. Under the Dave apps, look for ECAT SSC. Then select the usage of the apps. Here you can take reference of the I/O pins that are required to connect to the file. Let's minimize this help document as we need it at a later part. So to connect the I/O pins to the file, right mouse click on the ECAT SSC app. Then select Manual Pin Allocator. Now I shall take a bit of time to do the I/O pin configuration of the file with reference from the help document. So once we are done with the pin configurations for the file, we can actually save the configuration and close this window. After we are done with the file configuration, we shall generate the codes based on the configuration of the apps. So click on the generate codes icon. After the code generation process, a SSC or Safe Stack Code folder is created with the following files: the Infineon XMC ECAT SSC configuration XML file and a XMC ESC XL file. These two files are required by the SSC tools for the generation of the Safe Stack Code and the ESI file. From here, we shall switch over to the backoff SSC tools. Start the SSC tools by clicking on the SSC icon on the desktop. In this window, select Default and click on the Import button. Then we go to the project folder which we have actually created. Select the Safe Stack Code configuration file for XMC4800 which you find inside the SSC folder. Finish this by clicking on the Open button. Next, click on Custom and select the Infineon device inside the drop-down list and confirm with the OK button. With this, your SSC project is created. Next, we are about to do the variable mapping. Before doing this, let's preview the XMC_ESC Excel file in the SSC folder using the Microsoft Excel. Please note that to modify this Excel file, use only the Microsoft Excel and do not use the Day 4 Eclipse Viewer, as it does not save your latest changes. So as this Excel file already contains both input 2 push buttons and output 8 LED variables of the Relaxed Kit, so no modification is required. Therefore, we can save and close the Excel worksheet. Coming back to the SSC tool, we shall then import the Excel file, which defines the interface of the EtherCAT tools node. We can do so by clicking the Tools, Application, followed by Import. Then select the Excel file provided inside the SSC folder, followed by the Open button. Finish this process by clicking on the OK button. Now we can generate the new slave file by clicking on Project, Create New Slave Files. Here you will be prompted to save your SSC project, so you can click on OK to save the project in the same SSC folder. Once the project is saved, click on the Start button to generate the slave file. And finally, a pop-up window will indicate that the files are created successfully, and we can exit this process by clicking on the OK button. So with this, we can close the SSC tools and switch to Day 4. After the file generation process, the respective files are populated inside the SSC source folder. Please check the availability of both the generated Safe Stack Code and the ESI file. Do also note that the ESI file xmc.esc.xml needs to be copied into the TwinCAT folder later. The next step is to implement the input and output mapping. So open the file xmc_esc.c. Go to the function add input mapping. So edit this function with reference to the code snippet from the dev help document. And we do the same for function add output mapping, add application, and the file main.c. Now the EtherCAT project is completed and we can click on the rebuild button to compile the software. So when the compilation is finished, please ensure that there is no compilation errors. From here, we will download the software to XMC4800 by starting the debugger. Once we are in the debug environment, we can start the software to run with the Run button. From here, we shall put our focus on the EtherCAT master, which is the TwinCAT 2. In order to make TwinCAT know of the new EtherCAT slave device, we need to copy the ESI file generated by the SSC2 into the TwinCAT 2 IO directory. Now we are going to activate the TwinCAT System Manager from the Windows Start menu. So to create an EtherCAT master, we do a right click on IO device and select append device. Then select EtherCAT and click on the OK button. Here we will prompt on the network adapter that we are using on our laptop. For my case, I'll select the local area connection, which is connected to my laptop. So to bring the EtherCAT slave node into the network, do a right click on the EtherCAT master and select Scan Box. Here, the slave appears as a node on the bars of the EtherCAT master. And from here, you should see the run LED is flashing, indicate that it is on pre-op state. And from the inside of the EtherCAT master online window, you can see that the state is in pre-op. And the Q frame is counting up. Now we switch the master device to free run mode by clicking on the free run icon. The state should change from pre-op to op, and the cyclic counter is incrementing. From the fireboard, you can see that the run LED is turned on with no flashing. This actually indicates that it is on op state. Now let's have a look at the EtherCAT slave node. Here we will monitor the slave input button 1 on the XMC4800 Relaxed Intercap Kit. So go to button 1, online window. So when the button 1 is pressed, it will cause the level of the waveform to go from high to low. And the opposite happens when the button is released. And this behavior is also applicable to button 2. Next, I'm going to show you how we can toggle the LEDs of the XMC4800 Relaxed EtherCAT Kit from the EtherCAT master. To light up LED, we do a right click on LED 1 of the slave node and select online right, and inside the context menu we change the value from 0 to 1, and by clicking OK we can see that the LED 1 on the XMC EtherCAT fireboard is turned on, and the LED can be turned off by setting it to 0. And we can see that the waveform actually drops from level high to low. Now we have come to the end of the demo, and we will be collecting the questions which you have posed. So please stay tuned for the second part. I thank you for the question that you have posed, and I can see that there's a strong interest on this EtherCAT topic, as there are quite a few questions being posed here. However, I'll pick up some of the quite common questions from the list. The first question is, how many EtherCAT slaves can be connected in a network? From the background specification, it states that within an EtherCAT network, it allows up to 65,000 slave nodes. The second question is, how many ports does the XMC EtherCAT support? The XMC4800 or the XMC4300 is able to support up to 2 EtherCAT ports. The third question is, does the XMC EtherCAT support distributed clock for synchronized application? The answer is yes. The XMC EtherCAT microcontroller comes equipped with a 64-bit distributed clock for synchronized application. Now, I've come to the end of the webinar. I thank you for your participation and time.